take a look at questions 12 and 13. They are just like 10 and 11, just the numbers aren't quite as nice for these two problems. Okay, again, I have to find the x coordinate of the vertex. So I'm going to find that x coordinate by finding minus b over 2a. In this case, that's going to be minus negative 12. Watch your signs on that one. Some people get confused. You're inserting negative 12 inside those parentheses. That's going to make that positive. Then 2 times a, which is 4. So that's going to give you 12 over 8, which is going to reduce to 3 halves. And then I have to find the y coordinate. I'll substitute that in, so I have 4 times 3 halves squared minus 12 times 3 halves plus 9. That's going to give me 4 times 9 fourths minus 12 times 3 halves plus 9. They will cancel. That will become 9 minus 18 plus 9, which is a 0. So it looks like I have a vertex. Let me write that over here. A vertex at 3 halves and 0. That means my axis of symmetry is at 3 halves. My vertex is here. My y-intercept, I'll substitute a 0 in. Remember, you don't even have to do this, as long as you remember that the y-intercept is C. 1, 2, 3, 4, 5, 6, 7, 8, 9. I know I have a point of reflection across the axis of symmetry, and I can go ahead and sketch in my graph. It opens up. The leading coefficient is positive. Therefore, I have a minimum value. Remember, the minimum value is the y-coordinate. That minimum value is 0. Okay, let's take a look now at 13. 13 again, I have to find the x-coordinate. At minus b over 2a, that's going to be minus negative 3, and then 2 times negative 1, which again gives me 3 halves, actually negative 3 halves. So my axis of symmetry is going to be at negative 3 halves. And the x-coordinate of my vertex is at negative 3 halves. I have to find the y-coordinate. Here's my axis of symmetry at x equals negative 3 halves. To find the y-coordinate, I will substitute the value of x in to the function. So y is equal to negative 3 halves squared minus 3 times negative 3 halves plus 6. So y is equal to negative 9 fourths plus 9 halves plus 6. That's going to give me, I'm going to have to come over here, y is equal to negative 9 fourths plus 18 fourths plus 24 fourths. So that will give me 32 fourths which is 8. So I'm going to get a vertex at minus 3/2, 8. Right here, I have a y-intercept at 6, one reflected across the axis of symmetry. You can go ahead and sketch that in. And I have a maximum, and my max value will be 8. Okay? You'll definitely see a problem like that. I doubt that it will have fractions in it. I don't want you to get bogged down in that detail. So don't worry about problems like 12 and 13. It's unlikely that I would have a fraction there. Okay, let's take a look at number 14. It says a model for a company's revenue is R of X is equal to negative 15 P squared plus 300 P plus 1200, where P is the price in dollars of the company's product. What price will maximize revenue and find the maximum revenue? So when you look at this, you should know it's a parabola, and we're just going to briefly sketch a little bit. And you should know that it opens down because of the negative sign. It's reflected about the x-axis. So it's going to have a maximum value. That maximum value is going to be represented by price, P, and revenue, R of X. So when you find the vertex of this function, you've actually found the price in dollars, and you've actually found the maximum revenue. So it will give us the price and the maximum revenue. So minus B over 2A is going to give me minus 300 over 2 times negative 15. Gives me negative 300 over negative 30, or an x coordinate of $10. Substitute the $10 in to the revenue function, and that should generate the revenue in dollars. So to answer the question, the price that maximizes profit is $10, and the max profit is $13,500. Don't forget to answer the question when you do those, okay? So this is the answer to the question you were asked. Okay, number 15 says the equation for the motion of a projectile fired straight up at initial velocity of 64 feet per second is h equals 64t minus 16t squared, where h is the height in feet, t is the time in seconds. Find the time the projectile needs to reach its highest point, and how high will it go? So what is that highest point? So again, when you look at this, the graph looks like this. There's my maximum point. T time is on the x-axis, and height, h, is on the y-axis. So the x-coordinate will be time, the y-coordinate will be height, so that vertex. So we also, again, are going to find minus b over 2a. So minus 64 over 2 times minus 16. Negative 64 over negative 32 is going to give me 2. So at 2 seconds, the projectile is at its maximum height. Substitute the 2 into the function, so the height of this projectile after 2 seconds. Oops, sorry, that should just be a minus sign. So that's going to be, let's see, 64. So the height after 2 seconds is 64 feet. Okay, and I did have a student think about that question, and it was a good question he asked. He said, well, if it starts out at 64 feet per second, why does it only go 64 feet after 2 seconds? And the answer to that question is right here in this negative 16t squared, which is the pull of gravity on that projectile. So that's why it takes 2 seconds for it to go 64 feet. Okay, next section is going to be that section where you're asked to identify the vertex and the axis of symmetry. And these functions are written in vertex form. So these should be fairly easy. Okay, remember, vertex form is y is equal to a times x minus h squared plus k, where hk is the vertex of the function. So for number 16, the vertex is at minus 3, minus 4. The axis of symmetry is going to be at x equals negative 3. Number 17, there is no k there. You could put a 0 there if it helps you think about it. The vertex will be at minus 1, 0. The axis of symmetry will be at x is equal to negative 1. Number 18, I have a vertex at 4, 6, and an axis of symmetry at x is equal to 4. Let's take a look at number 19. It says write each function in vertex form. In order to write this in vertex form, you're going to have to find the vertex. So again, we're going to minus b over 2a. So minus negative 4 over 2 times 1. That's going to give me 4 divided by 2, which is 2. That's the x-coordinate. Substitute that 2 in, and you'll get the y-coordinate. In this case, the y-coordinate is 2. So you have a vertex at 2, 2. You know that your value of a is equal to 1 because there is nothing in front of that x squared. So writing this in vertex form becomes y is equal to x minus 2 squared plus 2. Number 20, again, minus b over 2a gives me minus 2 over 2, gives me an x-coordinate at minus 1. Substitute that minus 1 into the equation. Minus 1 squared plus 2 times minus 1 plus 5 is going to give me a y-coordinate at 4. So I have a vertex at minus 1, 4. Again, There's no coefficient on x, so I know that has to be a 1. So vertex form will be y is equal to x plus 1 squared plus 4. The last one we're going to look at in this video is number 21. Again, I need to find that vertex, so minus b, minus 8 over 2 times minus 2. It's going to give me minus 8 over minus 4. That's going to give me an x coordinate at 2. Substitute that in. And that will give me a y coordinate at 11. This time, when I look at my function, my a value is going to be equal to negative 2. So you can substitute that in for vertex form, where a would be. So y is equal to negative 2 times x minus 2 squared plus 11. And that's my vertex form. My vertex there was 2, 11. Okay, I'm going to end this video here, and then I'll move on to the next video for the rest of this review.